In this video, we'll cover the basics of bearings. To start with, what are bearings? Bearings are basically angles. 3 points to remember whenever we use bearings is 1, it is measured from the north. It is always measured in the clockwise direction and written in 3 figures. So here is a rough idea of the basic directions given as bearings. The north represented by 0, 0, 0 or 360 degrees. The east is 90 degrees. South is 180 degrees. The west is 270 degrees. Bearings are used in real life in real life for navigation. For example, pilots flying the plane or for navigating ships across the sea. Now let's get and find out how to measure the bearing of 1 point from another. Let's say we are given 2 points A and B, and we have to find the bearing of B from A. So the point to note here is that what are we trying to find? We are trying to find the bearing of B from A. First of all, we have 2 points A and B. We are drawing a straight line between both the points. Now, because it says that start from A, start from A, right? It says start from A. So because it is from A, what we do is we go to the point A, and at the point A, we draw a north line. Go to the point A, and at point A, we draw the north. Okay? And then to measure the bearing, what we do is we place the protractor at the north at point A, and the north is at the 0. Okay, this is a 360-degree protractor. And then check this line. Where is it? So the 0 is on the outside circle. So 10, 20, 30, 40, 50, 60. And hence we would write that the bearing of B from A is 0, 60 degrees, right? So that's it for measuring the bearing of B from A. So the point to remember is that you start from A. Draw the north, take your protractor and measure the angle. Now, what happens if we are asked to measure the bearing of A from B? Okay, that's also called the return bearing. Find the return bearing of A from B. Now, look at what they want. They want us to find the bearing of A from B. So the B is our starting point. Hence, at the starting point, B, what we do is we get the north and we place the north here. And what we are asked to find is the bearing of A from B. That means from the point B, from the north at B, we go all the way here. This is what we are asked to find. Now, in the previous slide, we found that the bearing of B from A is 0, 60 degrees, right? Now, since this is called actually the return bearing, right? The return bearing of A from B. And there are different, two different ways of finding it. You could find this measurement and then subtract it all from 360 because angles at a point are 360. So here we could find this and then subtract it from 360 to get the bearing of A from B. So 180 minus 60 would give me 120. So I would put 120 here, which means that the remaining bearing would be 360 minus 120, which would be 240. That means this angle or the bearing would be 240 degrees. Another shortcut to do the return bearing is to simply add the bearing 280 degrees. So you could also get the same answer if you were to simply add 180 plus 60. That would also give you 240 degrees. Now here's an example that you can try on your own. You can pause the video and try to find the return bearing of P from Q. We are given that the bearing of Q from P is 118 degrees. What we have to measure is the return bearing of P from Q. So the from Q, right? This is the word that we need to focus on. From Q. That means from the north at Q, we go all the way to the line joining P and Q, and this is what we need to find. So as before, we can solve it we can solve it in two different ways. 180 minus 118, right? So which would give us 62, which we can write here 0.62 degrees, and then we can subtract that from 360 minus 62, so which would give us 298. Okay. Or another way of solving it is a direct method, which is 118 plus 180, which would give us 298 as well. So you could use either method. You can find the co-interior angle and then go ahead and use the property angles at a point are 360. Either way, whichever one works for you, you can use that. So here, the bearing of P, or the return bearing of P from Q, is 298 degrees. Here are a few questions for you to practice, so you can just pause the video and then try to solve them on your own. First of all, let's read the question here. Find the bearing of B from A. Let's underline the keyword from A. So let's go to the point A, go to the north, and then from the north at A, come all the way to the line joining A and B, which is here. So this is a direct question. Already the answer is given to us. The bearing of B from A is 0.45 degrees. Remember, bearings are written in 3 figures. Find the bearing of B from A. Again, it's from A, so let's go to A. Then let's go to the north, and we can see that this is what we need to find, but what we are given is the other way around. This is what we need to find, this angle, which is missing, right? So what we do is we'll use the property angles at a point are 360 degrees. So what we can do is 360 minus 285, which would give us 75 degrees. So this angle here is 75 degrees. So the bearing of B from A, which was also like, we just had to find this, and that is 75 degrees. Now look at the next question. Find the bearing of A from B. Now look at the question here. It is from B, so we go to the part B, and then the north at B, we start at the north, and then we go all the way to the line joining B and A. That means this is what we need to find. This is the part that we need to find, this part of the angle. Again, we'll use the same property because angles at a point add up to 360. We are going to use the same property, 360 minus 110. so which would give us 250 degrees, right? So the bearing of A from B is 250 degrees, right? Now we go to another part, which is sketching a diagram. So you are given information and you have to convert that information into a diagram first of all before we start solving the problems. So this is just the basics of how we would sketch the diagram, right? This is just about sketching the diagram. Solving would require either sine rule or cosine rule. We'll go to that later on. All right, so to start with, the diagram shows the position of two towns, A and B. So that's town A and that's town B. They're drawn with their nodes. A rugby club R has a bearing of 110 from town A. So 110 would approximately come here because it's between 90 and 180. I'm just going to take the protractor and show you, although you can just draw an approximate line and that would be fine as well. So here's a protractor just for you to get an idea. So here you go. You don't have to actually use because in the MYP program, most of your problems you don't have to have it to scale. So that's your 110 degrees. All right, so we go to the point A, and as you can see, the protractor's north, the north line and the protractor's zero line are matching up. So we can draw it at 110 degrees. Okay, that's not very accurate, but yeah, okay. So that would be 110 degrees. Okay. Now, the next one is the rugby club has a bearing of 245 degrees from the town B. That means from town B, we need to draw 245 degrees. Now remember, 245 would lie between 180 and 270. That means it lies between the south and the west, right? So the line would, this is your south and this is your west. Now our protractor does not have 270 degrees. I did not take the full 360-degree protractor. This is just measures up to 180. So what I would need is I will have to do the remaining part of the 275 on my calculator, and find it out and do it on the protractor. So here I have 245 minus 180, which would give me 65. I'm sorry, 65. So what I'm going to do is, this is only because my protractor is not a full 360-degree one, okay? So when you also don't need to measure, you can just, if it's not to scale, you can just draw a rough sketch and that's fine, just as long as you label it properly and it's giving an approximate idea. So what I need is, here is my 0, 10, 20, 30, 40, 50, 60, and that's my 65. So I'll go take the protractor, the line, and I will just draw it at 65 approximately. Okay, there you go. We can, of course, all right, that's 65. Okay. And then go. Okay. Okay. So now let's label the diagram. So it is at a bearing of 110, which is what we drew here. So this is 110 degrees. And then the rugby club R has a bearing of 245. So 245 from the north all the way to here, that's 245 degrees. And then where the two lines meet, that's the position of club R. We can mark it there. Okay, so they said mark the position with an X, so let's do that. although there is a visible X there. Okay, so that's it. That's it. That's all there is to it. So this is just because in case you don't have to draw it to scale, you can just get an idea of how or where the angles are to be placed, and then you can draw them. So for example, if you're asked to draw 145 degrees, you know that 145 would lie between 90 and 180. So if you draw it approximately like this, that would be good. That would be fine. 230 would lie between 180 and 270. So as long as you draw your bearing like this and mark it on the outside, that would be fine as well. Similarly, for 315, you would have it going all the way to the quadrant between west and north, because here you have 270 and here you have 360. So you could just show the reflex angle like this and then label this as on the outside as 315 degrees. Right, so that's it for this video. We will solve actual problems using bearings in the next one.